Hi everyone, so I'm going to do another quick example on optimization and min-max problems. So this is a part 2 of the video. So part 1 I already talked about the 3 steps. I'll go over them again briefly. First is to model and make an equation. Second is to take the derivative and set equal to 0. And the third is to solve and interpret the results. So it's very straightforward. So let's try another example. So let's say you have to design you have to take a rectangular to make a rectangular piece of paper. Let's just make it a poster. So you have to design a poster, and it has to contain 50 inches squared of. So here's the problem. Design a poster that has 50 inches squared of print area and also has, let's see, 4-inch margins on the top and bottom. And then 2-inch margins on left and right. So again, let's just draw a quick sketch of what this would look like. So we have a rectangular poster here. You have an inside of print, and you have 50 inches squared of print. You have 4 inches top and bottom. Again, 4 of margin, and then 2 on each side. 2 inches of margin right here and right here. And you have to design this poster with all these things, and you want to minimize the amount of paper used. So this is where the min-max stuff comes in. You have to minimize amount of paper. So you minimize the amount of paper used. So let's just start labeling sides. Let's just say that this is X, this is Y on the inside. We're labeling the inside. We'll think about it in algebraic terms. And X and I'm taking these because I know the dimensions of this. And I say that X times Y, this is, the area, right? Times width is equal to 50. Then you can find Y in terms of X, and you can say Y is equal to 50 over X. So now you can describe things with one single variable, because you have X and you have 50 over X. So that's that. And the area of the whole thing is going to be X plus 4, because you have this X and you have 2-inch margins on each side, so it becomes X plus 4, and the height has Y plus 8, because you have 4 and 4, so it becomes 8. But instead of Y here, we can now use, since we discussed, 50 over X, so instead we're going to write here 50 over X, and it's going to be 50 over X plus 8. So you can, FOIL this out, and you get A is equal to 50x over X plus 8x plus, 200 over X plus 32. You get that, and this X and X cancels out, and you get it to be, if you simplify it, 8x plus 200 over X plus 32 plus 50, and you get 82. So that, now you have completed the first step. You've modeled it, you've modeled your problem, and you've made the equation. The next part is to take the derivative and set it equal to 0. So the derivative of this is A prime, and A prime is going to equal, so let's just do this A prime here, A prime is going to equal, let's just think about this a different way. Let's just rewrite A, but let's rewrite this middle term, so it's 200x to the minus 1 power plus 82. It just makes it easier to think about, because now you can use the power rule for differentiation. And then you can get A prime is equal to 8 plus, or actually minus, because it's n and then n minus 1. So minus 200x to the negative 2. So when you do write this, now this next part is to set this equal to 0. So you get 8 minus 200 over x squared, which is the same as x to the minus 2, is equal to 0. So you get 8 over 1 is equal to 200 over x squared, and then you can cross multiply, giving you 8x squared is equal to 200. If you divide 8 on both sides, you get x squared is equal to 25, and x can equal plus or minus 5, but in this case only 5 is the only viable answer because you cannot have, obviously, negative side lengths of this rectangle here. So now you have your x, and since x is 5, and we described here y is 50 over x, so that makes your y is equal to 10. So the overall dimensions of this poster that we made is going to be 5 plus the 4, which is 9 inches, by the 10 plus the 8, which is going to be 18 inches. So these are your final dimensions for the poster.